Okay, this is what we're gonna do today. Okay, tomorrow we're gonna review, like today I'm gonna do one more homework problem. So we're gonna do one more problem with this problem, and then tomorrow we're gonna review, and I'm gonna go over some of your homework problem. I'm gonna make some comments, okay? Because some of you guys turned in your homework, I realized you didn't watch the videos, the lesson video that we did last Thursday, because a lot of you guys did not what I asked. Okay, you did something, but it's not what I asked. So I want you to watch your video, the lesson video, so you know exactly what is homework about. Because your homework, you turn it in. Some of you guys did really well, but many of you guys did something other than what I asked for. So I want you to, so I'm gonna go over India's work tomorrow because her work is exactly what I asked for. So I'm gonna go over that so you guys can look at how she did it, and then you can change your homework problem according to how she did it. And also, I want you to pay attention to what I did yesterday and pay attention to what I'm doing today, because your exam will be just like what I'm covering now. Because you have to find x-intercept, y-intercept, horizontal asymptote, vertical asymptote, domain, range, first derivative, critical number, critical point, second derivative, and inflection number and point, maximum, minimum, and then you graph. All right, so I rearranged your order of finding stuff, because like the homework that I gave you, I just put down what I think about it, okay? So now I rearrange your homework problem, the process, the steps of your doing your homework in this order. So when you do your homework, you can do this order fine, okay? You can take away the end behavior and then add graph to your homework problem, okay? All right, so anybody have any questions so far? If you do, you can put in a chat or you can raise your hand. Anybody have questions? Okay, next thing, I want you to say I'm here so I can see that I can do the attendance. Okay, so let's go and do it. So everybody write this down on your notebook. Okay, so you know what I'm doing. Because if you do not write this down, later on we're gonna be confused. Like remember yesterday, critical number that we found was 3, but I put, no, the critical number was it, I cannot remember, 0, right? But I put a 2 and -2 because I didn't look at my previous problems. So make sure that you write this down on your notebook so you can follow with me. Okay, I'm waiting for everybody to write this down so we can follow, we can do together. So everybody write this down. I'll give you about 2 minutes. So write this down so we can go over this together. Not just watch me, but put in your notebook. All right? Okay, is everybody good? Can I move? All right, Stephanie, are you finished writing down? Okay. Shalia, are you finished writing down?
Yes, ma'am.
Okay, so I'm gonna move right now. Okay, now let's everybody do the same thing we're doing. Write this down on your notebook. So I'm gonna find the first one. X-intercept, what X-intercept means? You have some number, but the Y has to be what? 0. That's what X-intercept means. So I'm gonna do 0 is equal to x squared minus 2x plus 4, everything divided by x minus 2. Then we're gonna do just like we've been doing, get rid of the denominator. So multiply everything by denominator. So that make this one cancel out. But you know, anything times 0 times anything is what? So 0. Okay, so now you have 0 is equal to x squared minus 2x plus 4. Now we're going to do common, we're going to do the factorings. So -2 times -2 gives me positive 4. 3 and 4 and 3, do we have this number? Or did I write down wrong? Okay, so 1 and 4, 2 and 2, 2 times 2 is 4. So it does not give me this. So I wrote down this problem wrong. Okay, so sorry, you guys. I wrote down problem wrong. There's supposed to be, I wrote down my problem wrong. Because this is supposed to be, I need to get -2 and +2. So give me a minute. Okay, so this is supposed to be positive, -4. So I made a mistake. So it should be -4, not -2. -4, +4. So please change that problem. So you need to change that into -4. Okay, so I made a mistake. Sorry about that. So the problem is supposed to be -4. All right, is everybody with me now? Does everybody follow me? Okay, so watch this. The problem should be y equal to x squared minus 4x plus 4, everything divided by x minus 2. I made a mistake writing down as -2 instead of -4. So problem should be -4. Now, everything else should be same. So we're gonna multiply by denominator x minus 2 with x minus 2 each side. So now we have, again, this is a -4. Okay, then, does everybody see that? This, I can rewrite it as x minus 2 times x minus 2. All right, so which means I can find my x-intercept. I'm gonna set. So I'm gonna set x minus 2 equal to 0, equal to 2. Well, this is exactly the same thing, right? So x equal to 2. So I have the same thing. So I have x-intercept, only one x-intercept, which is 2, 0. That's my first one. All right, now let's the second one. Now I gotta find the y-intercept. Y-intercept means x is a 0, but I need to find whatever the y is. Okay, that's what y-intercept means. Y-intercept means x is a 0 and cross y-axis and whatever the number. Okay, it crosses y-axis, so x is a 0. So we plug it in. So now we have, that means we have a y is equal to 0 squared minus 4 times 0 plus 4, everything divided by 0 minus 2, which is the same as what? 4 divided by -2, which is the same as what? -2. So y-intercept 0, -2. So we got second step done. All right, so far so good. Now we're gonna look for vertical asymptote and domain, vertical asymptote and horizontal asymptote. So I want you guys to follow me. Are you writing this down on your notebook?
Does it matter which one we find first, or is it just
Finding,
horizontal?
no, you can find whichever first. It doesn't matter. Yeah, it doesn't matter. I just like to find x-intercept first and y-intercept first, but it doesn't matter. Okay. Next one, I'm gonna do Which one did I want to do? I'm just trying to follow my own step. So horizontal asymptote. So let's do the horizontal asymptote. Remember, horizontal asymptote has 3 cases, right? When the numerator power, remember 3 cases. Do you remember that? I'm just gonna write down, review one more time. What's the review? If I have this equation, call it, say, a times x to the n, say b times x to the m. Remember that equation? Say, I'm gonna call it g of x, dot, 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 plus dot, dot, dot. It doesn't matter, but I'm just gonna look at only this, the first leading term, right? So if n is bigger than m, what happened? No asymptote, right? No horizontal asymptote. If n and m is the same, what happened? Y is equal to a over b. If, yes? Somebody have a question? So we have 3 different cases, okay? So if the numerator power is bigger than denominator power, you have no asymptote, you have a slant asymptote. If numerator power is the same as denominator power, your y equal to a over b. The leading coefficient is your horizontal asymptote. And if the numerator power is less than denominator power, and your y equal to 0 is your asymptote, horizontal asymptote. So let's look at our case. What is our problem? Our problem is y, so y is equal to what? X squared minus 4x plus 4, everything divided by what? X minus 2. So what is my case? Which case? 1, 2, 3. What is my case for horizontal asymptote? Number 1 or 2 or 3? Thomas, do I have a horizontal asymptote? Does this problem has a horizontal asymptote? Thomas? No, that's right.
No, it don't.
No, that's right, because numerator power is more than what? Denominators, everybody see that? Right? The numerator power is 2, denominator power is what? 1. So this case is what? We're gonna say no horizontal asymptote. Okay, so that's our no horizontal asymptote is my number 3. Okay, number 4. Vertical asymptote. The vertical asymptote means we gotta do what? Our problem is this. So what is my vertical asymptote? And tell me. Who's gonna tell me? Let's see the names. Chevian, what is my vertical asymptote and why? Wait a minute, you weren't here yesterday. Diavian, what is the vertical asymptote for this problem? And why?
I don't remember you going over the vertical, so can you like show me right fast?
Yes, okay. The vertical asymptote is what? You look at the denominator of this rational equation. So vertical asymptote means when the denominator becomes 0, that x makes the denominator equal to 0 is your vertical asymptote.
Oh, is this where we set the denominator equal to 0?
Yes.
Okay, well it'll be positive 2.
That's exactly right. So I'm gonna set x minus 2 equal to 0, so x equal to what? 2. So that's what may be your vertical asymptote. So x equal to 2 is a Rutherford estimate. Because why? When x equal to 2, the function is what? Undefined. Just think about it. You cannot have 0 over some number which is what? Undefined. Okay, is everybody good? All right. So looking at number 3 and 4, now I can do my domain and range. So domain is what? Every number, of course, every number what? So all real number except which number? 2. Or I can say what? Or all real numbers except x equal to 2. Or I can say what? Negative infinity to 2 union with the 2 to positive infinity. Any of this is fine for your domain. Okay, is everybody good? Any questions so far? All right, now range. So we did problem, remember we didn't have any horizontal asymptote. Remember the horizontal asymptote will tell me which y we cannot use. But in this case, it says I can use any y's, right? So I'm going to say, okay, that means I have a y for everything. So I'm going to say all real number. Or say all real number. Or you can say negative infinity to infinity. Okay. Any of this will do. You can use any of this. You can just write down, I think your homework problem in a web assignment, they ask you to do this way. Using an interval notation. When they say use interval notation, this is what they're asking you to write. This is an interval notation. Okay, is everybody with me? All right, next. What else do we need to find? Exponential one is the horizontal asymptote, vertical asymptote, domain and range. Now let's take the first derivative. Now we're gonna do calculus. Okay, so let's take the first derivative. We're gonna do just like we've been doing. I'm gonna call that to be my f. I'm gonna call this denominator to be my g. So f is equal to x squared minus 4x plus 4. So f prime is 2x minus 4. Remember, we got the quotient rules, right? My g is equal to x minus 2, so g prime is equal to 1. So I'm going to rewrite it here. So y prime is equal to g times f prime minus f times g prime, everything divided by g squared. So we're going to just plug it in. So g is x minus 2. F prime is 2x minus 4 minus x squared minus 4x plus 4. Everything multiplied by 1. And everything divided by x minus 2 squared. Okay, so let's just simplify this. We're just going to FOIL that, right? So 2x squared minus 4x minus 4x plus 8. Does everybody see that? X times 2x, 2x squared, x times negative 4, negative 4x, negative 2 times positive 2x, negative 4x. Negative 2 times negative 4 give you positive 8. Next one. The next one, just simply just multiplying them out. I mean, just take them out with a negative in the front, opposite sign. Okay, now let's cancel out anything that we can cancel out. Okay. So what do we have here?
Professor, doesn't the last 4 on the equation, since you distribute the negative, turn -4 at the end?
Oh yes, negative. Thank you, thank you, thank you. You are very right. Did you ever, because of this negative sign, this become a negative, that became a positive, that become a what? Negative. Thank you. Thank you, Stephanie. Okay, now let's combine. Right? So that gives me x squared. What else? Does anything else to combine? Nothing for -4x. I can combine this +8, -4, which gives me +4. That's very interesting. I have the same numerator, but the denominator just become squared. Okay, is everybody good? Now, what do I need to do? How? So I found my first derivative, so I'm great. I'm done with that. Number 8. What did they say? Number 7, critical number, and critical point. So we're going to do that now. So this is actually 6, isn't it? I'm going to do critical number. Critical number means what? You put y prime equal to 0, and then what? Find for x. That's what it means by critical number, right? So I'm going to do x squared minus 4x plus 4, everything divided by x minus 2 squared. I set them equal to 0. And I'm going to get rid of the denominator like we always do. Then we can cancel that out. And that times that is still 0. So we have x squared minus 4x plus 4 equal to 0. And this is happened to be something that we already did it. So we know, which is x minus 2 times x minus 2, which equal to 0. X minus 2 equal to 0, or x minus 2 equal to 0, so it happen to be just equal to 2. So we have a 1 critical number, x equal to 2. So I'm going to say x equal to 2. Okay, so now how do you find the critical point? India, how do I find the critical point? Is she here? She's not here, okay. Jalen, how do I find critical point? Okay. Sorry?
Plug the 2 in for the x's.
That's right, in y equation, right? Thank you. So my equation y is equal to x squared minus 4x plus 4, everything divided by x minus 2, but I'm going to plug it in 2 as my x. So I have a 2 squared minus 4 times 2 plus 4, everything divided by, that is, it is a problem. Then what do you get? You have no critical point at 2 because you get a 0 in the denominator. So it'll be undefined. It is undefined, so you don't have a critical point, which means you're not going to have maximum or minimum. that this just tells you, you don't even, there is no max or min in this case. Does everybody see that? Your denominator is 0 here. Because of that, you have a what? You got undefined. You don't have y value that would give you maximum or minimum because it's undefined. Because this is undefined, you can say there's what? No minimum or maximum. So like when you're asking for this problem right here, find a max or min, you know right away, you're not gonna have a max or min. Okay, and then let me tell you why that's true. Okay, so let's say note. Your problem is y equal to x squared minus 4x plus 4, everything divided by x minus 2, right? So when we factor the numerator, what do we have? X minus 2, everything divided by what? X minus 2, isn't it? So if I cancel out the common factors, numerator and denominator, what are you left with? X minus 2. So x minus 2, your graph looks like this. That's what your graph looks like. So linear equation does not have a max or min. Okay? When I say max and min, that's usually relative maximum and relative minimum, which means you compare it to something else to see which one is the lowest, which one, which value is highest. For linear equation, it's just going straight up. So there's no relative minimum or relative maximum. So that's why you don't have minimum or maximum. Does it make sense to you? So this problem actually I don't have to do anymore. But since it's asking you to find a second derivative, so we can move forward to find the second derivative. But the problem-wise, we're pretty much done because you know for sure, you know how your equation looks like. This is what your equation looks like. And you don't have a maximum and you don't have a minimum. Okay, but let's go and find the second derivative so we can practice. So I'm giving you the problem. The examples I'm using is from your book. The reason they're using it is like they want you to know not every function has minimum or maximum. So this is a good example that you don't have maximum or minimum. But we're gonna keep move on because I want you to practice finding first derivative and second derivative anyway. Okay, who has questions? Davian, did you have a question?
Yesterday when you found the critical point, you had used the second derivative instead of the first one. So when it
is critical number is always first derivative. Okay, I know what you're talking about. So you were asking yesterday, I plug it in critical number into second derivative to find whether they're maximum or minimum, right? That case, I had a critical point. Thank you for asking me that. Okay, so Davian is asking me about this. Yesterday, we found the second derivative and then plug it in the critical number. You see that? I plug it in critical number into my second derivative to figure out whether I'm going to have a maximum or minimum, right? But now look at the critical point. Last time, the yesterday problems, I had a critical point. So I had critical point, but I didn't know whether this is max or min. I didn't know, right? So how can I find this critical point is a max or min? I have to take a second derivative and plug it in my critical number into the second derivative to see whether the second derivative is positive or negative. If the second derivative is positive, I will have minimum. This critical point will be a minimum. If my second derivative is a negative number, this critical point is what? Max. Are you following me, Davian?
Yes, ma'am.
Okay. So the difference is, yesterday I had critical point, but I didn't know whether that's going to be max or min until I take my second derivative and plug it in, the critical number into second derivative. Like today, I do not have critical point. Okay, because y value at the critical number is undefined. So that's because of that, I know for sure I have neither. I don't have a maximum, I don't have a minimum because I don't have a critical point. But yes, I'm gonna keep taking my second derivative so we can practice, okay, finding a second derivative. But if you choose to do the other problem, that would be fine too. But let's just practice finding a derivative again. So just for our, just for practice. But we already know this is what graph looks like, the linear equation. Okay. So now let's look at the, so I'm gonna do 7, 8, second derivative. So we got this. And we also got this. Okay, so I'm gonna take the second derivative. So we're gonna do, just like we always do, I'm gonna put that to be my f, my numerator to be my f, my denominator I'm gonna use as a g. All right, so f is equal to x squared minus 4x plus 4, f prime is 2x minus 4. G is equal to x minus 2 squared. G prime is a little more complicated right now. 2 times x minus 2 times 1. I did a the chain rule. So now I can just plug it into our formula. So y prime is equal to g times f prime minus f times g prime, everything divided by g squared. So y prime is equal to g, which is x minus 2 squared, f prime, 2x minus 4 minus f, x squared minus 4x plus 4, g prime, 2 times x minus 2. Everything divided by x minus 2 to the 4 now, right? 2 times 2 give you 4. You could just square. All right, so now we're just going to simplify it. I want you to practice this just for your, so double prime. I'm keeping double prime, okay? Double prime. So now look at the common factor. So I have a x minus 2 is my here. That is my common factor. So I'll bring that out in the front. So whatever is not a common factor, we'll put it in the inside the parentheses. So we have x minus 2 times now it's for 1 power. Then I have 2x minus 4 minus x squared minus 4x plus 4, and then multiply by 2, and I'm going to close all the parentheses. Okay, so I just took out the common factor x minus 2. So whatever is not a common factor, I put in a black bracket. Now we can just simplify it, and we're done. But before we do that, can I? We can make that to be 3, right? Because the common factor x minus 2. This and that cancel out, right? This power is 3 now. I'm gonna make this to be a little bit smaller letter so that could come up. Now that's 3 power now. Okay, it used to be 4, now it's 3 because x minus 2 will cancel out. So now, let's just simplify it. Y double prime is, you FOIL this. So you have 2x squared minus, and minus 4x plus 8 minus x. You got 2 in the front, so we're going to put 2x squared plus 8x minus 8. Okay, so we're just going to simplify things. That and that cancel out. That and that cancel out. In fact, you get a what? You get a 0. Okay. So y double prime is 0. That's why it's also, it give you, it tell you, okay, this is exact. This is a very, very, very good problem. Remember, when you put the y double prime with the critical number, if this is a positive, you get a what? Minimum. Y double prime with the critical number, if it's less than 0, what do you get? Maximum. So when you have a y critical number, this is your new, it's equal to 0, what are you going to say? Undefined. Okay, so that's why you have a 0 here. So algebraically, also you confirm this graph does not have a maximum or minimum, relative maximum or minimum, because you got a 0. So we're done for today's work. So let me look at the your homework problem. So this is your homework problem. So let's reorder this. So we're not finding this. You can cross that out. Okay. So I want you to find, well, starting with find the x-intercept, y-intercept, and find the vertical intercept or horizontal intercept, and then find a domain and range. Okay, symmetry, you don't have to worry about it. I can cross that out too. And then you're gonna find, so this, the order should be for x-intercept, y-intercept, vertical asymptote, horizontal asymptote, and domain and range, and then find first derivative, and then you're gonna find what? Critical number and critical point, and then find a what? 7, 8, 9, 10, and then find the second derivative, inflection number, inflection point, max or mean, and 14 graph. That's the order. Okay. So same homework problem, you can rearrange your homework problem orders so it'll be easier for you. So this is the order that I want you to do. So your number 2 homework problem is just like our lessons we did it. So I want you to practice one more time. Okay, make sure that you know how to do it.
So do it need to be in this order, or it don't, like, long as everything there? Because I already started.
Yeah, that's fine. As long as you did, that's fine. But what I'm saying, this order would be easier for you. That's what I'm saying. But if you already have started, you have no problem, that's fine with me. Yeah, it doesn't matter. Okay. So what I want you to do, let me see. Because I didn't put any homework problems in the, so let me see. Give me 1 minute. Look at your notebook just for a minute, okay? While I'm getting another homework problem, another good problem that we can do together. Okay, As I said before, you can use your notebook. So if you don't use this, if you don't apply this, if you don't write a good note, you're gonna have a problem. So make sure that you practice.
Professor, can you scroll down to the bottom so I could get the last part of the note?
So right here, is this the one?
Yes.
Okay. Okay, I'm gonna do another problem with you guys. Let's look at another example. Say if I give you this problem, so another example. So this is a little bit simpler than the ones we've been doing. Let's say if I give you this problem. Okay, so let's do this problem. We're just gonna do like quickly do this problem. All right, let's do it. So first thing, we're gonna find the x-intercept, right? And which means you have some number is x, but we have a 0 to be y. So we're gonna do 0 equal to x squared plus 1, everything over x squared plus x squared, excuse me. Okay. Okay, the problem is wrong. I wrote down wrong. The problem shows there's no plus 1. Okay, so this is the problem that I'm gonna get. I'm doing an exercise homework problem from your 3.6, number 15. That's what I'm doing right now. All right, so that's what you have. In that case, we'll just do always redo. So you get 0. So 0 equal to x squared. So that means x is equal to 0. So your domain, I mean, your x is a 0. So your x-intercept is a 0, 0. But if this, whenever you have a 0, 0, that means your y-intercept is also same. Does everybody see that? Because you said when y is equal to 0, you get x. And x equals to 0, you get a y. So this problem is actually a lot easier than other problem. You just already figured out your y-intercept. Y-intercept is, it means 0, and then you would figure out what y would be. But we already know from previous problem, the previous problem says y is 0 when x is 0. And when x is 0, y is 0. So we already know in this case it's 0, 0, because whatever this equation is going to the origin, okay? So your x-intercept and your y-intercept that happen to be same. All right, so is everybody with me now? Okay, next thing. So x and y-intercept I don't have to do it separately because it's origin. Going to the origin, your x-intercept and y-intercept, they happen to be same. Next one. And finding a asymptote. So vertical asymptote. That means I'm gonna put what? Denominator equal to 0. So x squared plus 3 equal to 0. And x squared, x2 equal to -3. So x squared, so which means x has to be equal to -3 and plus minus, which means it's imaginary number. So I do not have asymptote. So we know no vertical asymptote. Because this is what? It's imaginary number. We don't care about the complex number right now. We only worry about the real numbers. So since square root of -3 is an imaginary number, we don't have a real number as an asymptote. So there's no vertical asymptote. Okay, horizontal asymptote. So since their power is what? I'm only worrying about this case. So their power is the same. This case is m is the same as n. So what is my asymptote then in that case? A over b, isn't it? The coefficient, leading coefficient of that. So what's my leading coefficient? There's no number there, so that means that's 1. So it'll be 1 over 1, which is what? 1. That's your horizontal asymptote. Okay, whatever the reason, it doesn't let me go down anymore. Let me see. Okay, sorry about it. All right, next one. So I can talk about domain. It looks like I can use any number, right? Remember, I didn't have any vertical asymptote, so it's all real number. Number 6, what about the range? I can use everything except which one? The horizontal asymptote. So I can use -infinity to 1, union with 1 to infinity, or I can say all real number except y equal to 1. Y is not equal to 1. So I can use every number except 1 because horizontal asymptote is at 1. All right, next one. Let's find a first derivative. Since y is equal to x squared divided by x squared, what's my problem? X squared plus 3. So we always redo, same thing. I put that to be my f. My numerator to be f, my denominator to be g. So my f is equal to x squared, f prime is 2x. G is equal to x squared plus 3. So g prime is equal to also 2x. So let's find y prime. Y prime is g times f prime minus f times g prime, everything divided by g squared. So we have x squared plus 3, everything multiplied by 2x minus x squared times g prime, which is 2x, everything divided by x squared plus 3 to the square. Then we just simply expand them for them. So if you distribute it, you have a 2x to the third plus 6x minus 2x to the third, everything divided by that again, x squared plus 3 squared. So that and that cancel out. Our answer simply is y prime is equal to 6x everything over x squared plus 3 to the square. So that is our first derivative. Now we gotta find a critical number. So critical numbers, I need to set them equal to 0. So y prime equal to 0, so which means I'm going to set this equal to 0. All right, so now we everything by multiply by denominator, we always do, excuse me, that to the square. So that and that cancel out, that's still equal to 0, which means 6x equal to 0. So x is equal to 0. So critical number is x equal to 0. Okay. Next one. So now let's find the critical point. So we plug into that number, right? So we're going to do y equal to y at 0 is equal to, I'm going to put the 0 square, everything over 0 square, and then plus 3, which is a 0 over 0, which I get a 0. The critical point happened to be same as our, the critical point, the x-intercept and y-intercept that happen to be all same thing. This case is 0, 0. So critical point is 0, 0. All right, now class, DADN especially, did everybody see that? I have a critical point. So that means I will have either maximum or minimum, but I do not know what this is. So we got to take a second derivative to verify it, okay? Right now, we have extrema, but I don't know that's maximum or minimum. So we're gonna find that in a minute. So second derivative. So we got y is equal to x squared over x squared plus 3, and y prime is equal to what? 6x over x squared plus 3 over square. Now let's find the y derivative of y double prime, okay? So I'm gonna do the same thing like we did before. That's my f. I'm gonna put that as my g, denominator to be my g. So f is equal to 6x, f prime is 6. G is equal to x squared plus 3 to the square. G prime is equal to 2 times x squared plus 3 to the 1 power, and then 2x. That's your derivative of this. Derivative of that, it'd be what? 2x. So I just use the chain rule, okay? Chain rule and a power rule. So we're gonna plug it into our formula again. Formula g times f prime minus f times g prime, everything over g squared. So that is equal to, I start with the z, x squared plus 3 squared f prime is 6 minus 6x times g prime, which is 2 times x squared plus 3 times 2x. And everything divided by g squared. My g is this, x squared plus 3, now to the 4 power. All right, we always do the same thing again. Find the common factor. My common factor is x squared plus 3. So I will bring them out. That's my common factor. So bring them out. So whatever is not a common that stays inside the parentheses. So it'll be whatever is not 2 times 2x. Everything divided by t squared. I'm going to rewrite that problem as x squared plus 3, and then the other one will be third power. So that and that can cancel out. Now remember, this is only a third power. Now just simplify the numerator, then we'll be done. So simplify the numerator. So that is equal to 6 times that. So 6x squared plus 18. That would be 424. All right, just simplify that. So you take away 6, it'll be negative 18x squared plus 18, everything over x squared plus 3 to the third. So that's my f double prime. I mean the second derivative. All right. Now, I need to know whether I have a, so inflection point means you set them equal to 0. So let's do the inflection point before we forget. Inflection number. So just make it easier. Okay, just look at this pattern, you guys. Whenever you're looking for a critical number, what are you working with? You always move your, you get rid of your denominator, then you end up with what? Numerator equal to 0, isn't it? So I'm just gonna tell you, I'm gonna skip this part, say don't worry about just multiplying by new denominator by same number to get rid of it. But just think to yourself, that's what you're gonna do. That's the skip that's the step I'm gonna skip. So I'm gonna just say right away, say, okay, I know I can get rid of denominator by multiplying by denominator. So I end up with this, negative 18x squared plus 18 is equal to 0. To find my critical points, or inflection numbers, things like that. Okay, so you got this. So that gives me negative 18x squared is equal to negative 18. So x squared is equal to negative 18 divided by negative 18, which is 1. So which means x is equal to negative 1 and x is equal to positive 1. So I have a 2 inflection points. I mean, inflection number. That's it. They're very interesting. So 2 inflection number. Okay. To find the inflection point, what do? I need to plug that into my y. So you need to plug it in here. Y of 1. So 1 to the 1 square divided by 1 square plus 3, which gives me 1 over 4. And the other one is 1 over negative 1, which gives you also same thing. 1 and negative 1, because negative 1 squared divided by negative 1 squared plus 3, which give you 1 over 4. So I have a 2 inflection points. So I have inflection points. So I have, which is negative 1, 1, 4, and 1 and 1, 4. Okay, I'm done almost. I need to find whether I will have a maximum or minimum. So y double prime of a critical number. What's my critical number? It's 0, right? So plug in a 0, so you get 0 square plus 3, which is giving me what? 0 over 0. Again, you get a 0. So what do you know now? Do I have a, does this a max or min? Yes or no?
It's undefined, right?
Yeah, it's undefined because again, it's 0. So even though we had a critical point, which is 0, 0, that is not, it's a neither max nor mean. That's very interesting. So your book has a lot of interesting problems. So I'm gonna see what we know right now. What was my, that graph told you your intercept. So this origin is your x-intercept, y-intercept, and your critical point. Okay, so that's very interesting. So that case, I need to, so in your graph is this. And then what do I also know? It says the horizontal asymptote was what, 1? That's my horizontal asymptote. So my graph, so looking at this graph, what can I say about this graph? When x gets bigger, and so does y, so it's increasing. And same thing for here. They're increasing, but there's no critical point. So we're gonna finish this part, the last part, the graphing part tomorrow, because it's already 11 o'clock. I'm sorry for holding you guys too late, but do your homework problems and make sure that you watch videos, okay? The videos from yesterday should be up there. I don't upload my videos anymore. My student worker does it. So if you subscribe, that whenever she upload, the notification will go to you. So make sure you subscribe so you know when she uploaded, then you get it. So she will helping me out with uploading my the videos. So I don't know when she does it. So you need to just subscribe it. So make sure that you understand, you get it whenever she does it. Okay. And I will see you tomorrow. We're just gonna review one more time and do your homework problem. And if you have questions, you need to ask me tomorrow because you have an exam on Tuesday over this. And that's chapter 3. And the chapter 3 has a section 7 and 8. That is not part of this exam. That one I will do after exam. Okay. So section 7 and 8 and 9, that is not part of chapter 3 exam that you would take this this Tuesday. That one I will do after your exam because I want to do programming with those. That'll be different lessons that I'm going to do. All right. I want you to have a good day and I will see you tomorrow. Thank you. Okay, bye.